Hi friends, in this video I am going to explain binary heap tree and how to perform insert and delete operation on it. Binary heap tree has two main properties. First, it is a complete binary tree, which means all levels of the tree except possibly the last one are fully filled and the nodes of last level are filled from left to right. Second is heap property. The key stored in each node is either greater than equal to or less than equal to the keys in the node's children. If the key stored in each node is greater than or equal to the keys in the node's children, then the heap is referred as max heap. And if the key stored in each node is less than or equal to the keys in the node's children, then it is referred as min heap. Now let's see an example of max heap tree and its array representation. Array representation of binary heap tree has two advantages. First, as heap tree is a complete binary tree, there will be no wastage of array space between the two nodes. Second, parent and child node index can be computed by simple arithmetic computation. No need to maintain separate link field. A node I left child is stored at 2i plus 1 and its right child at 2i plus 2 and its parent is stored at floor of I minus 1 divided by 2. Here 42 is stored at index 6. Its parent node index can be calculated as floor of 6 minus 1 divided by 2, which is 2. Now let's see how insertion is done in heap tree. Insertion algorithm is simple. First, insert the key to the end of the array, then bubble it up while the heap property is broken. Swap the current node with the parent node if they are in wrong order. Here, key 50 is inserted to the end of the array. Since 50 is greater than its parent 29, it will be swapped with it. Then 50 is compared with its new parent 45, and since it is greater than 45, it will be swapped again. Now 50 is compared with 99. Since it is lesser than 99, it will not be swapped, and now heap property of the tree is restored. Now let's see the Python implementation of inserting a key in heap tree. These three methods will return the index of parent, left child and right child respectively. These methods will check whether the current node has parent, left child, right child or not. This method simply swaps the two node values. In these two methods, insertion algorithm is implemented. First, the key is inserted to the end of the array. Then heapify up function is called, which will bubble up the key until the heap property is restored. Time complexity of insertion is order of log n, where n is number of elements in a heap. Now let's see how deletion of root node is done in max binary heap tree. Root node value, which is max in heap tree, will be replaced by the last array value. Now new root value is shifted or bubbled down until the heap property has been re-established. Please note that the downward moving node is swapped with the larger of its children in a max heap tree. Here 99 will be replaced with last value of array, which is 29. Then array size is reduced by 1. Then new root 29 is bubbled down until it reaches its correct position. It will be swapped with 63, then 57. Now let's look at the Python implementation of this deletion of root node. Here I have defined two methods. Delete root method will replace the root node with the last array value and shrink the array size by 1. Heapify down method will bubble down the new root until the heap property is restored. While traversing downward, root node will be swapped with the larger of its children, and get max child index method will return the index of max child. This method will be used by heapify down function. Here is the output of the insert and delete operation we performed on heap tree in this video. That's all for now. Thank you guys for watching this video. If you liked this video, don't forget to share it with your friends and subscribe to my channel. Inshallah, I will be making similar educational videos in future. Bye.